Yeah, science. So whatever we discussed, slow recap, and from recap we'll pull up, right? So we discussed about matter in last class. And as I write the items, I'm going to say a little bit about them. I expect that you must have studied and come. If you have not studied, then I don't increase my blood pressure anymore by scolding anyone. Matter. Anything that occupies space and has got mass and can be felt is called matter. Then we learned about that matter is composed of tiny particles. And whatever I'm writing is important today from your course perspective. Okay, tiny particles. These particles can be in the form of either atoms or molecules. This is what we had learned. Also, some things about these particles. We learned that the particles have space between them. Space between them, right? And we discussed a lot about how do you prove that they have got space between them. You mix sugar in water. So how is the sugar getting mixed in water? Must be that sugar is a matter which has particles. Water is also a matter which has particles, and the sugar particles are getting into the space that is there between the water particles. We also saw potassium permanganate getting dissolved from chunks to water, then colored water to colorless water, and the color splits. So they have space between them. These three are very important. The next one, we said that there is also an interparticle force. Okay, there is an interparticle force which actually will hold the particles together. Otherwise, the particles would be spread across like marble balls and they'll go in any direction. So particles, see, the idea is like this. If this much is a small portion of matter, let this be a piece of bread. Now there will be millions and millions of particles inside it. Now how are those particles? Those particles have got space between them. One thing we studied. And they have also experienced something called interparticle force. Interparticle force means if there are two particles, then there will always be a interparticle force of attraction. Force of attraction. And this force of attraction actually binds the particles together. This is also something that we had discussed. And the third point, we also said that the particles are in motion. Particles are in motion, right? This also we had said by Brownian motion, though not in your syllabus. You remember pollens spread on a water on a petri dish is seen to do some zigzag movements. We'll discuss more about this today. So it says that these particles are also in motion, right? And then one aspect which we will discuss a lot today is that these particles are associated with thermal energy. This is what we will discuss today. Okay, these particles are associated with thermal energy. If anyone has got any doubt, like point number one, particles have got space between them. We discussed extensively on that. Interparticle force of attraction. Now, what is interparticle force of attraction? Two particles, two adjacent particles are held together, right? And this held together happens due to a force of attraction between them, and that force of attraction is called the interparticle force of attraction. As you go up in higher classes, we call this as intermolecular force of attraction, or at your level interparticle is also fine. So one thing that is understood, if this force of attraction is stronger, that means the particles will be held much more tightly, and if the force of attraction is weak, the particles will not be held tightly. ये तो common sense बोलता है ना. If two people have a strong piece of attraction, it will be difficult to divide them. And if the attraction, unity is strength, and if the unity is not there, then it's very easy to divide them. The fourth thing which I said was that particles are associated with thermal energy. Now, when I look at any particle, right, this is a piece of matter. This is a piece of matter, and this piece of matter is comprised of many particles. One of them is this, and say I have this particular particle, which can be an atom or a molecule, will have some thermal energy. It cannot be zero. It will always have some thermal energy. Thermal word is an analogous to the word heat energy. There is thermal energy. Now your question can be, sir, do all particles have the same content of thermal energy? No. Right? Everyone has thermal energy. Like there is little bit of naughtiness in everyone. Everyone is born with little bit of, what to say, cunningness. Fox is cunning, right? Everyone is born. तेरा सब कोई सोचता है. It depends. Somebody thinks a little bit more, somebody thinks a little bit less. So every particle would have heat energy. Now, as you increase this energy, ये भी समझना है हमें. How can I increase this energy? Suppose you apply energy from outside. How will you apply energy? By heating. When we heat something, suppose you supply more of heat, then the heat energy content, I already have some heat energy with me and I'm being additionally heated. So my heat energy content will go up. As the heat energy content goes up, this particle starts to vibrate. Question is, sir, was it not vibrating when there was a thermal energy in it? Yes, particles are always vibrating. They are never steady and they are never stationary. They are always vibrating. Once you give more heat and you add heat, this vibration starts going up. Understood? So suppose there are, say, 10 particles or 20 particles stacked together. It's just like how you see oranges being set up by a fruit vendor. So the particles are in that manner, and all the oranges are like little bit vibrating. As you heat it more, this vibration increases. And if you heat it more, the vibration starts becoming vigorous slowly. So if you add heat energy is like an external energy that you are applying. That will actually cause what? The interparticular force. So now what happens if two particles vibrate much more randomly and much more vigorously, they will now start separating from each other. So what happens? The interparticular force starts becoming weaker. So this is another thing that you should understand, that the and based on this, all questions you will be able to answer. Interparticle force of attraction. Have you understood what is interparticle force of attraction? The force which actually binds two particles. I have got two particles with me, and this particle will be pulling him, and this particle will be pulling the other particle. This is the interparticle force of attraction. Now, once I supply heat, as soon as I supply heat out here, so what will happen? This will start vibrating. This will also start vibrating. As a result, we have interparticle, we have some space between them. This space starts to increase. There will be a difference created between them. If the space increases, what about the force of attraction? It reduces. Force of attraction is always inversely related to the distance of separation. If the distance is near, the attraction is more. If the distance is more, the attraction is less. Are you getting these ideas? This is what you have to map. If two particles are close together, then their force of attraction is higher. If the force of attraction is higher, the interparticle space is less. At that time, the energy will also be less. But if you supply more energy, the particle starts vibrating. And once the particle starts vibrating, they will separate out. And if the space is more, the force reduces. ये समझ में आया? यही हमें जरूरत पड़ेगा बार बार. कोई चीज यहाँ पे, just leave this, particles are in motion. I'll discuss anything that you feel I should tell you once again and you have not understood. Please don't hesitate, because if you don't understand this logic, you will not be able to answer questions later on. Not matter, the particles of matter. That is at a very, very microscopic level. They are, everyone is associated with some inborn amount of energy. Once you have energy, you are not stable. Okay, let me give you one example. The content of energy in a body is just opposite to its stability. Let's try and think. You must be hearing about many children who are very, very, what you say, the parents are fed up of them, right? Every day, they don't sit idle at home, continuously running here and around. And then when the child sleeps at night, the house cools down. So what do you say? This child has got enormous amount of energy. There's a lot of energy in this form. Whenever a body has more energy, the body is never stable. For example, I ask you that get inside a bus and sit on the floor of the bus as the bus moves. At that, when your height is less, your energy is less. So you're very comfortable. The floor is clean, you can sit, no problem. Now I ask you, get onto the terrace of the bus and stand on the bus as the bus moves. Do you feel confidence? No, you don't. Your stability is less. Whenever energy is more, anything, this pen, right now this pen is kept on the table, it is stable. If I take this pen and try to put it here, it is unstable. So if you have energy, you are not stable. So every particle inborn has energy. That energy cannot be zero. Cannot be zero. So there is some energy content there with every particle. And if you have energy content with a particle, that particle will continue to vibrate. What I am doing is that, and let's see the configuration. Particles are close together with each other. So there is a definite space. A space defines how much is the amount of attraction between two particles. Have you understood? As if you supply more energy to a particle, if you supply more energy, then these particles will vibrate now more vigorously than they were vibrating. Due to this vigorous vibration, the interparticular spacing starts increasing. That means they are defeating their force of attraction. So what is happening to the force of attraction? The force of attraction is becoming weaker and weaker. Take a new refrigerator. There is a lot of attraction between the door and the rubber padding on the body and the door, rubber padding on the body. So it closes. If the refrigerator has become 10, 20 years old, the force of attraction reduces. So the space is created. Have you understood? Any other question that you have here? Because if you don't understand the logic, don't do that. Okay. If you don't understand the logic, then you will not be able to go ahead. So particles have space between them. There is an interparticle. So please understand, whenever you look at matter, matter means particles. How are the particles arranged? They are arranged in arrays. Just like an orange seller sets up his orange. Do they have some space between them? Yes. Is there an attraction between them? Yes. Do they have some inborn energy within them? Yes. And due to that energy, they are continuously vibrating. So what happens if you externally provide more energy? If you provide more energy, vibration is more vigorous. If the vibration is more vigorous, then what happens? The spacing increases, the force reduces. Sir, what happens if you pull out energy? I can take out energy also. How will I take out energy? By cooling it. Once you take out energy, then what happens? Their vibration comes down. Bacha has lost energy, so he'll go and sit in the sofa. So his vibration will reduce, but you cannot take out 100%. And if the vibration reduces, the space reduces. Vibration reduces, space reduces. The force of attraction wins over. Clear? It will become clearer now as we get into it. Particles are in motion. One of the examples I gave you was the pollens that you had dropped on a petri dish, right? Think of some more nice examples, okay? Now let's suppose there's a very nice example, like say for the incense sticks, or the agarbatti, the incense sticks. They are they're lighted at one corner of the room. How are you smelling the smell till here? Right? So those gases which are coming out after the agarbatti has been lighted, those gases are carrying that aroma or that fragrance. Now those gas particles must be moving from that place slowly and slowly. You didn't go there, but you're smelling it. Perfumes. Now some more interesting thing. Okay, here we will understand one more aspect, which is a term which is not used in your grade 8, but we will use in grade 9. So we'll learn that. Let's understand this. Say my flat number is 1303. Okay, now we are at 1303. The flat above me is 1403. And say suppose I have cooked some nice biryani. Biryani has aroma, right? The first person who gets into my room will immediately get in and say, sir, you made biryani, number one. Got it? The person who is staying above me will also smell and say, aaj lagta hai the downstairs people have made biryani, because gas rises up. So it is carrying. So you're getting a fair bit of idea about that particles are always in motion. Otherwise, the person did not come and visit my house. Here we have one term that we define in chemistry, which we call as diffusion. Diffusion. Diffusion you will be learning in 9th, but try to understand. It's very easy. As you enter my room, and I have actually cooked biryani in my house. So this room will be called as a region of high concentration. means there is a lot of aroma of biryani present out here. Do you agree? Because we have cooked biryani. A new person starts to come into my room and say, suppose this is his nostril. His nostril does not have these particles right now. Have you understood? His nostril region will be known as the region of low concentration. The movement of nature is such that particle movement will always happen from high concentration to low concentration. So as soon as this person enters my room, he has a region of low concentration. Are you getting it? And the particles will immediately come and hit him. This process is called diffusion. And he initially will get a sort of a shock. So have you made biryani? It's smelling very nice. Now make him rest for some 10-15 minutes in my house, or say 10 minutes. Within 10 minutes, this entire aroma of particles of biryani will get into his nostrils and all. So he will also be converted into what is called a region of high concentration. After that, person number 2 is now coming into the room. Now who is low concentration? Person 2 is low concentration. He will come and say, biryani, sir. And he will be very zapped. I am smelling it. This fellow is not questioning. He has already questioned 10 minutes back. Have you understood? After 10 minutes, he no more finds a new smell in the house, because the concentration level between the house and his nostril is now equal. So unless there is a difference, you will not smell anything wrong. Now take him outside and make him play some 5-10 minutes. Again bring him to the house. Again he will be on a region of low concentration. So when we spray perfumes and all, they generally say that perfumes and all are sprayed behind ears at this points. Why? Because generally the temperature of these places are more. So if the temperature is more, then the aroma particles which are here sense more temperature from here. So they are getting supplied with energy. They will vibrate more vigorously, and they will be increasing their space of separation and flowing out. When I spray perfume on my body, I want others to smell that perfume. Yes or no? So that's why perfume gets radiated out, and your nose is on a region of low concentration. The same again with body odor also. The same thing will happen with body odor also. Or the same thing if you're moving through some trash zone. Why do you immediately get a stinker? Because the trash is high concentration. You are on a low concentration. So diffusion, we always say diffusion is the process in which particles of matter move from regions of low concentration to high concentration. Now start thinking about the agarbatti example. The agarbatti was lit in one corner of your house. That zone became high concentration, and the entire house is right now at low concentration. So slowly those particles will start taking up, and once the whole smell becomes equal in the house, you now no more detect a new smell. Have you smelled a rotten rat anytime? That's why there is an English proverb that says, I smell a rat here. Rat, if it dies, it will give its order within one day, and it will be terrible. You will ultimately find out where it is. So that is also diffusion. Bottom line is, particles of matter are also in motion. So will you remember these? Have space between them, have amount of thermal energy associated with them, they have space between them, and they have an interparticle force of attraction. Based on this, we are now in a region to study what is known as states of matter. States of matter. How many states can matter exist? And to study states of matter, the 3 points that will be important for us is, number 1, interparticle space. If you can understand these 3, you can give all answers. Then interparticle force of attraction, interparticle force of attraction, and 3, the content of thermal energy. How much thermal energy is associated with the particles? So if we look at the 3 states of matter, matter has been grouped under solid, liquids and gases, and see how easily you will be actually able to, what do you call, differentiate. It will become very easy for you. Yes. क्यों इतना देर पढ़ा रहा हूं, इंटर पार्टिकल लिखने के बाद समझ में नहीं आ रहा? इतना देर से तो पढ़ा रहा हूं ना, पिछले क्लास में भी लिखा ना। चलो इंटर पार्टिकल रामा रावणा लिखा है, लिख ले। दिस शोज योर अटेंशन इन द क्लास। नहीं समझ में आने की जरूरत ही नहीं है ना, इतना देर पढ़ा रहा हूं ना, इतना देर पढ़ा रहने से आप क्यों नहीं समझे? आई हैव नॉट रिटन, हैव आई रिटन एनी न्यू वर्ड आउट हियर? नो, आई विल बी वेरी वेरी हार्श फ्रॉम नाउ ऑन. I have not written any new word. What I have written here is what I have written there. Your point is that you did not even write when I wrote this thing. When I wrote this thing, that time you were busy placing your pen between the spiral curls of your book. Tick, tick, tick. वो खेल रहे थे ना? उसने भी देखा तुम्हें खेलते हुए. Nivedita was also watching you. My eyes go all through. तो खेलिए please. यही चीज मैंने यहाँ पे लिखा है. I have not written anything new. And I'm keeping on saying, please, when you come 1 hour to my class, dedicate your 1 hour, forget everything that is happening in and around you, and put your attention here. If you have not understood something, I'll tell you. What a foolish question if you ask, I'll not repeat that. That just shows your attention in the class. Have I written anything new? No. I said that even before writing it, I'm going on uttering. Can you tell me the 4 things? चल बता दो, 4 चीज क्या है? No, particles occupy spaces matter. What about the properties of these particles? 4, I'm giving you 4. There are 4 properties. I want the correct language. Not very correct. Go ahead. We studied this last class also. Last class also we studied. Did you open your books in the last 8 days on this chapter? No. If you would have opened, it would have been right on your lips right now. Can you go ahead? We are still 2 less. So now you are trying to think. Last class we learned 8 days you got time. Exactly after 8 days I am teaching, if I am not wrong. Then also you didn't study. And now in sitting on the front bench I am teaching. Still you are not absorbing. So are you understanding what is distraction? Just coming to the class, that means it is as good as you can sit in that room and I give you a carom board, play carom board. I'll not tell parents that he played carom board. आपका concentration नहीं है क्लास में. Concentration रहेगा तो ऐसा नहीं होगा. और फर्स्ट बेंच पे बैठ के पेन को किटिक कर रहे हो, नहीं तो खेल रहे हो. You are disturbing my concentration. I don't use a book when I teach. Anyways, bless those who study and bless those who are yet to study. My job is be true to your work so that tomorrow solids, liquids, and say gases. Let's apply common sense and let's apply these parameters, okay? The first thing that we say about solids is that solids are something like a dairy milk, definite shape, okay? It can have a definite size and has a definite volume. Do you agree or not? One dairy milk chocolate, nicely frozen, has a definite shape, has a definite size, and has a definite volume. Start actually mapping this story to it. This story. Why is it so? That means if I look at a solid, it's very good. Its particles must be extremely closely packed. Why? So if they are so closely packed that their space between them is very less, force of attraction is very, very high. And what do you comment on the thermal energy content? The least. Because if they were having thermal energy, they should be, they are vibrating. But if they were having more thermal energy, they would have vibrated so much that their space would have increased. And you would have won or defeated that interparticle force of attraction. And that's one of the reasons that when you break a dairy milk also, it will give you a sharp edge or one corner will come out. Because it doesn't want to break. You are applying additional force to break it. You could have broken the dairy milk, but can you break a piece of iron? You can't break a piece of iron. And they are very, very, now start thinking. Solids have a definite shape, definite size, and definite volume. What can you interpret from here? That the solids, the particles are very closely packed. Very closely packed. How? What do you mean by that, sir? Okay, take some marbles and try to put them in jar. Go on putting them in jar in such a way that you are trying to encash maximum amount of the space in the jar. Last में एक नहीं जा रहा ना, ऐसे करके घुसा दो, and then close the jar, and you move it in such a manner that you don't hear any clinking sound of any of the marble balls. Have you understood? They are dense, compact. Now it has become very dense. Have you understood? Dense. And solids are very dense. Now the next thing, if you comparatively, let's say, see another thing, solids are incompressible. Incompressible means if you are a good solid, say for example, solid means proper solid. Incompressible to a large extent. However, if you take wood and you try to compress wood, it will still get compressed. But can you take a railway track and try to compress it? It will not. It will not. But 100% no one is incompressible in this universe. This is very dicey statement. Please understand. Solids are incompressible, or shall I use a better word? I'll like solids have the least compressibility. Have you understood what is compressibility? Compressibility means by the application of force, if you are able to reduce volume, then something is called compressible. By applying force, if you are able to reduce the volume, then that thing is called compressible. Now let's say a sofa cushion. A sofa cushion is also solid, but it is, if you compare a sofa cushion with an iron plate, whom will you say that which is more compressible? The sofa cushion is compressible. What will be your comment on the particles of matter? The sofa cushion is actually made up of sponge, and in sponge the particles of matters are very, very loosely packed, right? Now say when you are loading a lot of clothes inside your suitcase or your travel bag, after that you can compress it. But if you are loading 5 or 6, say, iron pads and all, can you compress them? No, you can't compress them. So solids have least compressibility. That actually tells you one more thing, that they have least space between particles. If you are able to compress, means you are able to reduce volume. That means particles must have been brought together after you compress it. How did they come together? That means there was space. Solids do not have space between them. Have you understood? But at that time, it is a very subjective word. A piece of paneer is also solid, but you are able to squeeze it with your hands. So there is a bit of compressibility, but not that much, not that much. If you see in liquids on the same thing, I will say liquids have definite volume, but not, liquids have a definite volume, but do not have definite shape and size. Very interesting. A 1 liter mustard oil poured in different vessels, what will be the volume? 1 liter only. क्या दिमाग लगाओ? 1 liter water in different containers will be 1 liter. But what about the shape? It will take the shape of the container in whichever you are actually pouring it. What about the size? It takes the size of the shape in which you are pouring it. Suppose I have brought 1 liter milk in a bottle. I can empty the 1 liter milk in a casserole. Still the volume is 1 liter. So liquids have a definite volume, but liquids don't have a definite shape. Neither do they have a definite size. How will you like to attribute that? That is because in liquids, particles are not that closely packed as compared to the packing that you see in solids. The same thing you'll study till 11, 12. A little bit higher order. There you will study what is the angle between the particles, what is the crystal structure. So in liquids, particles are loosely held. What will we use the word? Particles are loosely held. As a result, particles have a freedom to spread up from one another, but not that much also. So a liquid takes the shape of the container in which you are pouring it or storing it, but the volume remains the same. 1 liter water, if it's transferred from one bottle to another bottle, the volume does not reduce. The shape changes and the size changes. So let's comment on these things. Why do liquids why do liquids not have a definite shape? Liquids do not have a definite shape because the particles are not packed as closely as compared to solids. Particles have a degree of freedom to move. So if somebody tells you between liquids and solids, who has more space between them? Liquids have more space between them. What about the interparticle force of attraction? The interparticle force of attraction in solids is more. They are closely held. That's why they have a shape. In liquids, like when the teacher is in your classroom, everybody is sitting in one place. So you are held in one place, right? If the teacher is not there, then you are moving. But you are still moving within your classroom only. You're not still getting out of your classroom. So, and if somebody tells you comment on the content, can you stop doing that or keep it here? You're sitting on the front bench. That distracts me. What about the content of thermal energy? In solids, the thermal energy content is the least. इसीलिए ये सब शांत बैठा हुआ है. What about in liquids? The content of thermal energy is more as compared to solids. Now let's take a piece, let's take a chunk of ice cream and you slowly leave it into the atmosphere, just outside, ambient condition. So what happens? Outside temperature is more, the ice cream is at a lower temperature, so the ice cream starts absorbing the room heat. As it starts absorbing the room heat, what is happening? The ice cream particles are gaining thermal energy. If they are gaining thermal energy, what is happening to them? They are vibrating. And now they are vibrating so fast that they are slowly breaking those interparticular force of attraction. And then the space between the particles is increasing. So if the space increases to a considerable extent, change of state takes place. That's why slowly the ice cream has started to now melt. Same thing happens when you're heating paraffin or you are trying to heat any solid which will actually, iron also melts. But iron ke liye this is around 1400 degrees centigrade. Whereas for ice cream, any 1 degree or 2 degree temperature change is sufficient. By the time you walk, already the ice cream is, or if you're fighting with a chocobar in your hand, after some time, you'll be done with your vocabulary and only the stick in your hand. Rest of the ice cream has all fallen from here. That happens. Why? Because it is absorbing heat. So it depends upon how much heat a particular solid needs so that it can convert its state. That we'll study, which is known as melting. You will convert. So you are, if you look at everything, you have to look at a particle angle. We were closely packed. We were supplied with heat. As a result, our spacing increased, our force of attraction reduced, and spacing increased so much that we were forced to undergo a change of state and we became liquids. Have you understood? Okay. Now, if you see in compressibility, we will say a bit more compressible than solids. Sir, how can you say this? Obviously, liquids have more space than solid. Thoda to dabega, but not that much. You can do an experiment. Take a syringe and just, pull up some water and cover the syringes, the outlet nozzle, and try to push the plunger. Little bit you will be able to push. After that, you won't be able to push. You won't be able to push. So liquid is slightly compressible, not that much. But if you take solid, say for example, you take a syringe and you put some lot of salt or sugar in it, and then put the plunger and do it here. Kuch jayega hi nahi, thoda bhi nahi jayega. Solids are not compressible, whereas liquids are slightly compressible, slightly. And that pressure of liquid is what compressibility is what we use in cars for braking our cars. If you look for brakes, the brakes of the car always need something called a brake oil. And if there is lack of brake oil, it will immediately show on the instrument panel. And if there is lack of brake oil, the first thing that will happen is brake failures will take place. So how do you actually brake your car? The entire four wheels are connected with a master piston on your brake pedal, and there is a brake oil. The oil cannot be compressed. So when you are pushing the brake pedal, you are basically compressing that brake oil between all tubes, and the brake oil doesn't get any place to go. It straight away goes and starts giving a signal to the brake drum, jao, lago. And water has huge amount of due to compressibility of any liquid, you can do a lot of things. Compress a liquid and then just open it. That's what happens in your deo sprays. They're all compressed gases which has been compressed and converted into liquid. So when you spray, that is, you're opening it up to the atmospheric pressure. Again, a pressure difference. If you touch any deo spray, it will be very cold because it is highly compressed. And immediately if you spray, what happens? You are actually releasing the valve. When you spray, what happens? What is the thing that you do when you spray? You will have a valve nozzle like this, and upon that another nozzle will be sitting like this. When you spray, this one goes down and space is created. Outside is high pressure. Outside is low pressure. Inside the deo spray, it is in high pressure. So this will immediately try to escape. And while escaping, it vaporizes. That is the store. That's why we call atomizer. If you see room freshness and all, that's the concept of your LPG. The LPG red cylinder does not have gas inside it. If you are thinking that it has got gas inside it, you are wrong. It's liquefied petroleum gas. So inside the red cylinder, what is there? Liquid. And the liquid is stored at a very high pressure. And so whenever you open the regulator, you are actually allowing this high pressure gas to come in contact with low pressure. So high pressure will come to low pressure zone. While it comes, it changes its state and becomes gaseous. And at that time, it expands almost 400 to 500 times of its volume. Therefore, keeping the LPG in liquid allows you to store lot amount of gas. If you so much of gas, you compress. So what happens? The volume reduces and you have changed the state also, liquid. So what you see, that small cylinder, how is it running for 1 month? If you would have stored only gas, you would have needed almost something like this tower's volume. Are you understanding what I'm saying? So this will get clear from our next example. Okay. So these two are clear. If we see in terms of gas now, gases are what? Gases are like you brats in a school, no teacher, no principal. So keep roaming in the whole school. So in gases, we will say no definite shape, size, or volume. For example, if you take 1 liter of a gas, how can you say 1 liter? Because the gas was enclosed in a 1 liter container. Open the container in this room, then what is the gas's volume? The room's volume. Gases keep on expanding as much volume as they get. They are just like the wardrobes of girls. More and more space you give, every space is less for them. Yes. And whenever you open the wardrobe, you have to wear a helmet for your safety. Yes. Or else last clothes in and just close the door. Many boys are also like that, by the way. And then when you open, all is coming out. हाँ स्टीरियोटाइपिंग हो गया जैसे मैं भी लड़की बड़ा किया हूँ ना घर पे. अच्छा तो अच्छा है. How many of you boys also have wardrobes like that? Like if you open up, then you need a helmet to. So they say कि जगह नहीं है. You give one room, still the room is less. Give one flat, the flat is also less. So they are like gas particles. Gas, if you give space, it will go on expanding. It goes on expanding. That's why whenever there is a gas leakage in your room, they say open doors and windows. Why? Because if you open doors and windows, you are allowing more space. So you want that concentrated LPG, which is trapped in your house, to go and spread as much as possible so that it does not create any danger of ignition for you or a fire hazard for you. Okay? Take back my words. Okay, so no. So ये समझ में आया. Now somebody tells you, sir, why do you say gases do not have a definite shape? Now come back and answer from here. The interparticle space in gases is the maximum. What about force of attraction? No force of attraction. The mother of the gases never calls their children to home. So where are they seen? Sir, somewhere in Piramcheru, Pink Building, whole day they are roaming. Chapris. What about the content of thermal energy? Maximum. They have huge amount of thermal energy. Let us now try to see a form. Let us try to see one form here itself. Let's take a form called ice. Solid. Same item, water, right? Solid. What about the thermal energy? Least. But one fellow goes and starts giving heat to ice. So ice becomes what? Water. Right? So amount of thermal energy has increased. Definitely the spacing has increased. Interparticular particle force of attraction has reduced. You start heating this more, it becomes water vapor. Now the content of thermal energy is maximum. Got it? Then one fine day, you just take the stick out. Aa to ghar mein aaj. Start cooling it. So you are taking out energy. So what happens to the space? The space starts reducing. The force increases. So this first takes down the shape of water. Process is known as condensation. And then from here to here it is known as freezing. You can tie up all these things now slowly. Okay, what will be your comment on compressibility? Yes, high compressibility. And just now I gave you an example of LPG gas, the LPG cylinder. The LPG cylinder actually carries gas which has been compressed and converted into liquid. If you apply huge pressure and you reduce the temperature, the state changes. This is all you will study in grade 9. So from this aspect, let us see one cycle. I have something called a solid, then I have a liquid, and I have gas. Tell me, children, if you give heat out here, solid changes to liquid. If you give heat out here, then what will happen? It will change to gas. If you, Arnav, mute your line. If you take out heat from here, then gas will convert into liquid. If you take out heat here, then liquid will convert into solid. Solid converted into liquid is known as melting, and this is known as boiling. Boiling or vaporization. This is known as boiling or vaporization. And when you do from here to here, it is known as condensation. Okay, and when you go from here to here, it is known as freezing. Okay, can you now tell me one thing, that if I take a glass of water, now apply your common sense, let's see whether you can answer. Okay, and this is the month of June right now, and I have taken out a glass of water and I filled chilled water out here. Chilled water something at 10 degrees centigrade, right? After some time, what we will see, if we keep this water glass out, you will see droplets. Yes or no? A cold water bottle on your maths book means what? The book will start getting wet after some time. Why is this droplet forming, and from where this droplet is? Start thinking. हाँ, धीरे धीरे आंसर करो और सोच के आंसर करो. बोलो बेटू. So ये लिक्विड कहां से आया? हाँ, ग्लास के आसपास वाला एयर है. So what is happening? There is very good. There is air around the glass. This air around the glass is in what state now? Gaseous state, and it starts to accept the cold from this particular what? Glass का जो ठंडा पानी है, it starts absorbing the cold, right? As a result, its spaces starts reducing and it is getting condensed, and this is that particular water droplet which is happening. Next question, just try and think. When you start play, right? आप खेलते हो ना, खेलने के बाद आप sweat कर जाते हो, right? And you always feel that you should be sitting under a fan, which is actually very bad. if you see soccer players and all, immediately after the match, they will put up the jacket. Or tennis or badminton players, immediately, when it's in sweated condition, they will immediately pull up the jacket. Because otherwise, you are supposed to catch cold. Where does your sweat go? And why do you feel that aram comfortable out there? Where does the sweat go? Why do you feel that? Have you sensed it or not? Suppose I make you play football for 1 hour. You will be sweating, and then I make you sit in front of my bike like a kiddo, and we just go around and bike. Don't you feel that very enjoyable cold? Have you sensed that or not? Or cycle? Why that cold you are feeling? What is happening? The sweat on your body right now, like droplets will be there. Where did this? And by that time, the sweat will be gone. What happened to the sweat? The sweat started absorbing your body's heat. And in that process, the sweat from liquid converts into gas and evaporates out. From your body, heat has been taken out. So what happens to your body's temperature? It falls down. If you take out heat from a body, the body will cool down. Itna concept samajh mein aa raha hai na? From a hot body, if I take out heat, the body will cool down. Clear or not? So at that time, there is a potential chance of you catching cold. Solid, liquid, gas. We'll see evaporation also, because in order to understand evaporation, okay. Anybody has the idea of what is boiling? A process in which liquid is getting converted into gas. Then what is evaporation? This we will discuss in next class. Maybe we will not get time, but still we have time. What is the difference between boiling and evaporation? Thoda socho. Does a lake evaporate? Yes. It doesn't boil. The Peppa Pig muddy puddle evaporates? Yes, it evaporates. Sweat evaporates? Yes, it evaporates. So difference क्या है boiling और evaporation में? हाँ. नहीं, पर इतना सोचो ना, बॉइलिंग में आप हीट देते हैं, योर वर्ड इज करेक्ट. लाइक व्हेन वी बॉयल एग्स, अच्छा सुनो, व्हेन वी बॉयल एग्स, then definitely the amount of heat given is quite high. Do you think that same amount of heat is there on a cloudy day? When you go to the school, sometimes it is raining. By the time you have come on half day back, it's still not sunny, but the roads have dried. उतना हीट आ गया क्या? सूख गया पूरा? कहाँ absorb हो गया? All the clothes that you dry, you put them, कैसे सूख जा रहा है? How? There's a difference. What is happening? Something though is getting converted into gas. The soaked water or whatever water is there in a wet garment, that is automatically getting. Achha, tell me one thing. Now I am teaching, you all are there. Obviously, I am moving around. I am also sweating. So this t-shirt will be getting wet. In next 5 or 10 minutes, again, once you all are gone, I'll be sitting under the fan. The t-shirt will again dry down. It's not that wet as it is like you have poured some water on it. See the difference between boiling and it will get you absolutely clear now. Okay, let's see evaporation. Evaporation and boiling. Evaporation is a surface event only. Is only a surface event. Means only at the top surface evaporation will take place. Have you understood? Boiling is a process in which a substance, which is a liquid, will change to gas. Liquid changes to gas at atmospheric pressure. And if you are a pure substance, the other day I was saying about pure substance, like if you are, say, water or any compound, then your boiling point is always fixed as long as you don't change the atmospheric pressure. We say that the atmospheric pressure on Earth is 1 atmosphere. So if the pressure is 1 atmosphere, and if it is pure water, whether you are boiling it in Bandlaguda or you are boiling it in London, it will boil at how much? 100 degree only. Evaporation will not happen at a particular fixed temperature. So what is the difference? Let's see. What happens that if this is the liquid surface, then there are molecules in this surface, right? Ultimately, what is becoming gas means these molecules should have certain amount of energy and they should escape from liquid to gaseous phase. Molecules at the surface of a liquid, this is high level. Their energy content is much more than the molecules who are right below. Let's say this is a muddy puddle. So the molecules right at the surface, and some of them are just at the junction. Slight amount of energy if they get, they can just convert from here to here. This is known as evaporation. What happens in boiling is very interesting. Let's say this is your saucepan, right? Heat you will be giving from the bottom. So the first particle which will get heated up are which, and this is filled with all, say this is all water. So this is filled with water particles. Which are the first particles to get heated up? The bottom particles will be the first particles to get heated up. As they get heated up, they become lighter. Any hot thing rises. So they will rise up. As they rise up, what they will do, they will ask the cold ones, hey, niche jao, go down. They will send them right below. By that time, the cooler ones will again get heat up. Again, they will rise up and send. So what gets formed is something known as a current out here. It will keep on circling. This is known as convection current. A current घूमता रहेगा, घूमता रहेगा, घूमता रहेगा, and it will ensure that every goddamn particle now when they have attained the temperature of 100 degree, after that also if you are increasing the gas flame, you are actually foolish. Now you don't need to increase the flame. That is the advantage of using a pressure cooker. Once a pressure cooker has given a CT, there is no point in increasing the flame. Just hold it at a constant level because everything has started to boil now. Whereas in evaporation, the energy content of all the particles is not same. Here they will ensure that the energy content becomes same. And then boiling will take place. Boiling is not a surface phenomenon. Boiling is a phenomenon which is happening from top to bottom. So initially the bottom one will get heated, rise up, push them down, rise up, push them down. This is called a convection current flow. That's why we have ventilators at the top. Cold air comes from the window, hot air goes out from the ventilator. So convection setup is made. This is the difference. Evaporation is a process in which only the surface molecules acquire sufficient amount of heat to just change from liquid to gaseous state. Not that everything, otherwise the whole lake should have dried up. है ना? वो नहीं होता है. Now in our body also the same thing happens. Once sweat particles come up, these particles need some amount of energy to get converted. Where are they getting the energy from? From my body's heat. So they are sucking out heat from my body. As a result, the bubble of sweat is evaporated and my body has become cold. That is the potential chance of me becoming ill. Therefore, you are supposed to immediately put on your jacket once your game is over. But in our childhood, everyone has done that. I have also done that. That once you have played a good football or a cricket match and you're sweating, then start cycling. It gives you huge amount of comfort because you enjoy the breeze. Acha. Have you seen in village places where people have a earthen matka and they preserve the cold of that matka? How do they preserve the cold of that matka? So in this matka, they will put one gunny bag. Have you seen truck drivers carry this bottle and it will have a gunny bag, you know, the rice bag, jute bag, and that jute bag will be wetted and it will be spread across this matka. This water is very cool. What is happening? The jute fabric will be wetted and will be put around this. This wet jute fabric will be actually drying up in the process. So it is actually sucking heat. It is sucking heat from where? From the water which is inside. And this earthen pot has got pores in it. So it will take out the heat from the water. And after some time you will find on peak summer day, the jute bag has become ekdam papar jaisa dry ho gaya. So the boy will again go and again wet that jute thing and again he will wrap it around and keep it. Why does your mother put a cold handkerchief when you are having high fever? The cold handkerchief will then become hot. The cold handkerchief starts pulling the heat of your forehead so that your temperature comes down. And one more nice example. Say when your bus is ready in the morning and your hot cup of Bournvita has been made and you can't drink it. So what do? We'll take that hot cup and we'll put it in a bowl of water. Have you seen the steel? Suppose in a steel glass है तो सब चीज में खाली क्या जो बता रहा हूँ उतना मुश्किल है समझना. स्टील के ग्लास में somebody has made a hot Bournvita for you and they say you drink it now, but you can't drink it so fast. ठंडा करना है उसको. So what do you take? You take another big ball, fill it with water and put that glass in that ball. Slowly the water will get heated and the Bournvita will cool down. Or you take the Bournvita and you spread it. ऐसे ऐसे करना भी एक चीज है. Or you spread it. Tea. Have you seen people? Very hot tea, they will first pour it on the saucer. So once you spread it, the surface area increases. Towel. Wet towel, if you just put in a lump, will it dry ever? No. It has to be spread. The more surface area you give, more will be the rate of evaporation. So evaporation depends on what? Every clothes that we dry are dried by evaporation. They depend on what? Temperature, wind speed. Wind plays a very big role. Wind speed. Wind will be carrying away these molecules. Third, area. And fourth is humidity. If you go to Visakhapatnam and you put a wet towel outside your balcony, throughout the day also it will not dry up. Why? Because the humidity is very high. Same as in Chennai. The whole day you feel wet.
Yes, sir.
Right? That is because the humidity content is much more. So, we'll break here. Maybe in our next class, a little bit we'll see. For my side, the chapter, everything we have done. So, if you see in solid, liquids and gases, try to map this story when you study. If a solid has got more space, melting and boiling is something I need to cover a little bit more, which I'll do. If you are having incompressible means no space. If you are highly compressible means there is lot of space. Lot of space means what about your force of attraction? Very less. What about your thermal energy content? Very high. And you will be asked questions on these three. So you just cannot remember. You have to understand. And Arnav, any question, or Avian, somebody had a question in between. I stopped you all. कुछ है क्या बेटो पूछना? Okay. So then I will break up and see you again in